All right, here are the solutions to the section 4.3 activity on the fundamental theorem of calculus. So we're going to evaluate some definite integrals, and it asks you to sketch the area you found for each of these integrals. I didn't leave myself a lot of space here, but I'll do my best to draw some sketches here. Okay, so this first integral says the integral from 0 to 4 of cosine x dx. So the first thing we do is write down a function whose derivative is cosine. That is sine x, and we're going to evaluate from 0 to pi over 4. So that's sine of pi over 4 minus sine of 0, and we get root 2 over 2. And what have we just found? We found the area between cosine and the x-axis from 0 to pi over 2. So that cosine is 1 at 0, and it comes down to pi over 2. So we found this area right here. Okay, the integral from 1 to 4 of x to the 3 halves. Let's see, we add 1 to the power to get the antiderivative, so that's x to the 5 halves. We multiply by 2/5. Evaluate that at 4 and 1, and we get 62 over 5. What does this area look like? Well, we're looking from 1 to 4. X to the 3 halves at 1 is 1. And x to the 3 halves at 4 is 8. So this isn't quite to scale, but it looks something like this. Whoops, I don't want it to be a straight line. So it looks something like this. It's a somewhat parabola looking, and this is the area we found. Okay, x squared minus 9 from -3 to 3. Okay, well, let's see. What does that happen here? The antiderivative is x cubed over 3 minus 9x. We can evaluate that from -3 to 3. And if we're careful with our signs, SIGN, we should get -36. And then we can think about whether that makes sense. And I'll draw this picture down here. What do we know about this function? Well, at 0, its output is -9, and then it hits the x-axis at 3 and -3. So it's a parabola that looks something like this, so we would expect the answer -36 makes sense in this context. Okay, and then finally the integral from 0 to 2 pi of sine of x dx, its antiderivative is negative cosine. We evaluate that and we get 0. And again, this one makes some sense. Let me draw the picture. What do we know about sine? It starts at 0. It hits the x-axis again at pi. It hits the x-axis again at 2 pi. It reaches a maximum in here and a minimum in here. So that's the interval we're looking at. And really what this integral is telling us is that this area is being treated as positive. This area is being treated as negative, and they're the same area. And that's why this integral gives us a value of 0 because of the signed area. Okay, here's some more to evaluate. I didn't ask you to draw pictures, just evaluate. So the integral from -5 to 5 of pi, well, pi is a constant function. So it's a horizontal line. So this is just the area of a rectangle. And the width of the interval is 10. So the area is 10 pi. All right, the integral from 1 to 4 of 2 plus x squared over the square root of x. Well, here we can divide this into 2 pieces, rewrite those as fractional exponents, so that gets us right here. The integral from 1 to 4 of 2x to the -1/2 plus x to the 3 halves. And we can take the antiderivative of each of those pieces individually. We add 1 to -1/2 to get +1/2. We divide by 1/2, which is the same as multiplying by 2. And then we'd already seen the integral of this second piece above. Evaluate that from 1 to 4, and we should get 82 over 5. All right, the last one, the integral from 1 to 2 of 3u minus 2u plus 1 quantity squared. You could multiply that second term out and collect all like terms, simplify, and then take antiderivatives. Or this is actually a case where you can take the antiderivatives directly. So we get 3/2 u squared. We take the u plus 1, we raise it to a higher power, which is 3. We divide by 3. Then I would check, right? Because that's a clear chain rule for taking the derivative. So I would check here the derivative with respect to u of 2/3 u plus 1 to the third. 3 comes down. 3 times 2/3 is 2. We get u plus 1 to 1 less power, and we multiply by the derivative of the inside, which is 1. So the key here is that the derivative of the inside function is 1. So we're okay here in regards to the chain rule. And then we can evaluate those two pieces at 2 and -1, and we get -27/2. Okay, so there are the solutions to the 6 definite integrals here in the activity. Sorry that the pictures are a little bit crowded up here, but hopefully you can use that to help you do the homework in the text.